Hey guys, hopefully you can hear me. Geez, it's been a while since I've recorded a video. Please don't fast forward. Don't fast forward. Don't fast forward. Okay. Listen, the goal of this is to help you with with today's assignment. All right. So combined gas laws is what we went over yesterday. All right. One of the things we talked about in the beginning of the notes was so we have the equation P1 V1 over N1 T1. All right. If the two things are variables, sorry, I just put my kids down. It's been a long day, right? If the two variables are next to each other, okay, then it's an inverse relationship. So like as for pressure and volume, if pressure goes up, the volume goes down. And I can't remember what I said. I'm sorry. Again, it's been a long day, but it's an inverse relationship. Okay. If they're on top of each other like these two are, as pressure is increasing, the moles must also be increasing. So that's what I'm wanting you to look at here. So this one says, what would happen to the volume if the temperature is increased? Well, for volume and temperature, okay, they're above each other, so volume over temperature. All right, so this is a direct relationship. So if the temperature is increased, the volume is increased. All right. What would happen to the moles if the volume is increased? Well, volume is on the top shelf and moles is beneath it. All right, so if the volume is increased, this is also a direct relationship because if one thing's on top and another thing's on bottom, it's a direct relationship. All right, so the moles would increase also. Again, direct relationship means the same thing happens. Temperature, if pressure is decreased, all right, so temperature and pressure, so that's a P over T when we look at the equation. A direct relationship, I guess I didn't do a good job of mixing these up, I apologize. All right, so if pressure is decreased, all right, then the temperature is also decreased. All right, and then what would happen to the pressure if moles is decreased? Well, pressure in moles, P over N. So if one was asking about moles is decreased, then the pressure is decreased. All right. And I'm just going to add one more because I want you to see it and I forgot to put it in there. Okay. But what would happen to the volume if the pressure is, we'll just go ahead and say decreased also. All right. Well, if the pressure is decreased, the volume is increased because again, when they're next to each other, that's when you have that inverse relationship. Okay. So that's what number one's asking. So everybody should get number one right, right? For number two, convert each of the following Celsius temperatures to Kelvin. Y'all seem to get this pretty good yesterday, okay? Might need your calculator, might not, just depends on how good your mental math is. All right, but anytime we're going from degrees Celsius to Kelvin, we always want to add 273 to our number. Okay, so for all three of these, you're going to be adding 273 to tell me what the temperature is in Kelvin. All right. Now, sometimes we'll get our answer and it's going to be in Kelvin when we work out the gas law problems. If it's in Kelvin and it asks you to go back to degrees Celsius, all right, let's see, so here we added 273, right? Well, if we're trying to go from Kelvin to degrees Celsius, then we're gonna be subtracting 273 from the answer. All right, so 0 degrees Kelvin, we would subtract 273 from that to get our degrees Celsius. All right, remember, Celsius can be a negative number. Kelvin cannot be. All right, number 4, convert each of the following to liters. All right, well, if you look at the volume for yesterday's notes, it says that if it's in milliliters, to go from milliliters to liters, we move the decimal 3 times to the left. So it's like Beyonce plus one more, to the left, plus one. All right. So that'd be like having a decimal here because there's an imaginary decimal at the end of a number if there's not one present. And then we're going to move it over 3 times. So this one would end up being 1.000 liters. All right. You can do B and C on your own. All right, but it's 3 times every time. So if you're moving it over twice or 3 times here, you're going to have to add a 0 in front of it. So don't forget that. All right, number 5, convert each of the following to milliliters. Well, to go from liters to milliliters, we're going to do the opposite. Okay, we will move decimal 3 times to the right. All right, so again, it's the opposite of what we did here. I'm not even going to show you an example because you know what you're doing on this. All right, I know you do. All right, now for the fun part. At the end of class, I believe y'all were getting more comfortable with these kind of problems, okay? I will do a few of them with you, but I want you to try the rest on your own. You will be having a quiz over this tomorrow. And guys, if you do this worksheet, I will let you use the worksheet on the quiz and it will be helpful. So please keep doing this. And if you're this far in the video already, thank you. I'll stop talking and I'll keep getting to work because I know that's what you want to do. All right. So with the rest of the worksheet, we're going to be using the combined gas law, which is the P1 V1 over N1 T1 equals P2 V2 over N2 T2. All right. Number 6, I'm going to let you guys do this one on your own. Okay. But I will do number 7 with you. It says, what is the volume? So we're looking for a volume of 3.4 moles. So remember, moles is represented by the letter N. If the volume is 2.8 liters, so unit here is liters, liters is a volume with 7.9 moles. So there's another moles. All right, so again, first thing you do with these problems, underline and identify what variables you have. Okay, so here we're looking for a volume, so I'm going to put volume equals X. I don't know if it's 1 or 2 yet, so we'll keep going and figure that out. What is the volume of 3.4 moles of oxygen? So this volume goes with 3.4 moles. Now we know these two go together, so we can go ahead and make this V1 and N1. It says if the volume is, so that's our new volume, 2.8 liters with 7.9 moles, so N2, 7.9 moles. All right, so again, I've identified what the variables were and what we're looking for in the question. And then I listed them out and I looked at, okay, so what was the before and what was the after kind of thing. All right, so that's where the V1, N1, V2, N2 come in at. Then the next step is I'm gonna make sure that everything's in the right unit. Moles is moles, so that one's good. And my volume's in liters, which is perfect. So I don't have to move the decimal at all. So I can plug these numbers in just like I see them. Right, so P1, V1 over N1, T1 equals P2 V2 over into T2. All right, so we have, so sorry, just lost my train of thought. Okay, we have volume in moles, so we don't have pressure and we don't have temperature. So I can mark those out. So this is what I'm left with, and this is what I'm going to be plugging in. All right, so we're looking for V1, so I'm going to put an X over that. The N1 was 3.4 is equal to 2.8 over 7.9. All right, so yesterday, especially in some of my later classes, which tend to be more vocal, I was having a lot of people hesitant about cross multiplying. So I'm going to, on this Canvas page beneath this video, there will be another video or two about how to arrange these problems and how to cross multiply. So if you're stuck on that, maybe pause the video, watch those real quick, and then come back here to make sure you're comfortable with the algebra part of this, okay? So when we have fractions, we have to cross multiply. Cross multiply means I'm going to take what's on top of one fraction and multiply what's on bottom of the other fraction. Okay, so like here we have X, and I'm going to multiply it with the 7.9 over here. And I'm going to write it as 7.9x just because I like writing X second. It doesn't matter if you write X first or second. And then I'm going to equal that to 2.8 times 3.4. All right. Once I get this, now it's solving for X. Okay, to solve for X, I've got to divide it by 7.9 so that way I can get my X by itself. And I have to divide it by 7.9 on this side too. So in a calculator, you could do 2.8 times 3.4 and then divide that by 7.9. And if you put it in the calculator correctly, you should be getting 1.2 liters. All right. If you're not getting 1.2 liters, talk to somebody around you and just have them kind of walk through this part with you. All right. But if you are getting 1.2 liters when you calculate it, great job. All right. To the next page, because there's more, always more. We work hard in chemistry, and I'm proud of you for doing that. All right. I'm going to skip number 8, and I'm going to go straight to number 9. All right, and then I'm going to do number 11. So I'm just kind of doing the odd problems right now because, again, I want you trying out these problems. All right, number 9, a sample of 6.12 moles of ammonia gas, so moles is in, occupies 1.58 liters. Well, anytime we see liters, we know it's talking about volume at a temperature of 295 Kelvin. Hey, this is already in Kelvin, so we don't have to add anything. All right. If you lose some gas and only have 2.3 moles, occupying 1.20 liters, what will the temperature be? Okay. So there's our variables. Now let's list them out. It looks like this is pretty much like, hey, this is what we're starting with, and then we're going to change it. So this is what we're ending with. What's the new temperature? So N1 is 6.12 moles. V1, 1.58 liters. T1, 295 Kelvin. And then we have N2 at 2.30 moles. V2, 1.20 liters. And we're looking for that second temperature. All right. Or instead of a question mark, I'm going to put X because X is what I like to use. All right. So when I check, my volume's already in liters, score. Temperature's already in Kelvin, even better. All right. So Here's the equation. All right, and again, we're going to use this equation a lot, so you're going to have it memorized, but you don't have to have it memorized, but you'll get there. All right. So the only thing that I don't see on this list is pressure, so I'm going to mark that off. All right. And then I'm going to go ahead and start. So V1 is 1.58. And then divided by N1, which is 6.12 times T1 at 295. And that's equal to V2, which is 1.20 over N2 times X. So this is what I'm looking for here. We got those silly fractions again. So yes, you're going to need to cross multiply. Okay. Top of one fraction with the bottom of the other. All right, so this one, I'll kind of draw a line here so you can see what I'm doing. So it's going to be 1.58 times 2.30 times X is equal to the top of this fraction with the bottom of this fraction. So 1.20 times 6.12 times 295. All right. So at this point, I did not do this on my key that I'm glancing at as we're doing this, but or I didn't write it down. I did it, I just didn't write it down. But you're gonna multiply these two numbers and get your X value, and put X with it. You're gonna multiply these three numbers and write it down. And then you'll divide this answer by this answer to get X. And if that confused you, I am really sorry. Do whatever you know to do to solve for X at this point in time. And if you're really confused, ask somebody around you. They can probably clear it up for me a little bit better than I just said. And if I really confused y'all, talk to me about it on Friday, but hopefully it's not at that point. Because again, you're gonna have extra videos you can watch if needed. But if you did all this correctly when you solve for X, you should be getting 596 Kelvin. And I checked this one twice when I did make the key. So this is your answer. All right. The last one, number 11, I'm not going to do all of number 11 for you, but I am going to help you get started on it because historically there's some confusion with this question. It says a weather balloon contains 59.5 liters, so that's a volume, of helium at sea level, where the atmospheric pressure is 101.3 kilopascals. Okay, remember kPa is a pressure. The balloon is released from 4,000 meter mountaintop. Guys, we haven't said anything about meters, right? So this right here, this is just telling you that it's a tall mountain that you're releasing the balloon on, but you don't need anything with that number. So it's extra information. All right, so the balloon is released from a 4,000 meter mountaintop where the pressure is 61.7 kPa. Okay, remember higher altitudes have a lower pressure. What is the volume of the balloon when it's released? All right, so we're looking for our volume. All right, so I'll list it out and then I'm gonna let you take it from there, okay? Because you're rock stars and you can do it, all right? A weather balloon contains 59.5 liters of helium at sea level where the atmospheric pressure is 101.3 kilopascals. All right, so I know those go together, so I'm just gonna go ahead and make them V1, V2, or V1, P1. All right, the balloon is released from the 4,000 meter mountaintop where the pressure, okay, so the pressure was 61.7 kilopascals, but it wants to know what your new volume is. All right, so I've listed out this one for you, and I just wanted to help you because most people get caught up on this number. Again, extra information, but you can solve this Yeah, I know you can. All right, thank you so much for listening to this. Again, if you complete this assignment, you can use this on the quiz to help you out. And the quiz is only 2 questions long. All right. Um, yeah, I'm gonna stop talking and I hope you guys have a good day. I'll see you Friday.